Previously, we dealt with the different types of variations, direct, joint, and inverse. Let us have a review of each before moving on to our last type of variation. Let's start with direct variation. In direct variation, the relationship between the independent and dependent variable can be represented by the equation: the dependent variable is equal to the constant k times the independent variable, in which the dependent variable and the independent variable can be represented by any letter in the alphabet. So we can have here A is equal to K, and then we have B. This is our dependent variable, and this is our independent variable, which can be read as A varies directly as B. Now, the relationship of these two variables show that as the independent variable gets bigger, so does the dependent variable. And as the value of the independent variable gets smaller, so does the dependent variable. How about joint variation? Now, looking at the diagram, you can see that joint variation is connected to direct variation. It only shows that a joint variation is like direct variation, but with two or more independent variables. Say we have here C varies jointly as D and E, where our C is the dependent variable and our independent variables here are D and E. How about inverse variation? Okay. Inverse variation is the opposite of direct variation. So the relationship between the independent and dependent variables can be represented by this equation. The dependent variable is equal to k over the independent variable, in which again, these two variables can be represented by any letter in the alphabet. So we can have here, say we have m is equal to k over n, which is read as m varies inversely as n. So what does this relationship mean? It means that as x, or not x, as the independent variable gets bigger, the dependent variable gets smaller, or as the independent variable gets smaller, the dependent variable gets bigger. So the directions of the independent and dependent variable are not the same. Okay? Now, let's look into the operation involved between the constant and the independent variable in direct, joint, and inverse. In direct variation and in joint variation, notice that the operation involved is multiplication. How about in inverse? The operation involved in inverse is division. Take note of this. So we're done with the review. Let's move on now with our last type of variation, which is what we call combined variation. Do you have an idea of what combined variation is? How does it differ with direct, joint, or inverse variation? Let's find out. So we have the learning targets for this lesson. We have two. First is, I can differentiate combined variation from other variations. And the second one is, I can solve problems involving combined variation. So what is a combined variation? A combined variation is a combination of direct and joint, and also inverse variation. Okay? Now, say we have this statement, y varies directly as x and inversely as z. How are we going to translate this into an equation? Okay, take note. that I've told you a while ago that the operation involved between the constant in direct and joint is multiplication, while in inverse, the operation is division. So we'll follow these operations here in writing the equation. So we have y varies, do not forget to write k, directly as x, so that's multiplication, k times x, and inversely as z, mean to say that is divided by z. So that's how easy it is to translate mathematical statements into an equation involving combined variation. Let's have first a practice on translating mathematical statements or situations into an equation. Okay. You have done this also in direct and joint, even in inverse. So what I want you to do is pause this video for a while, take a minute to answer, and then after answering, you're going to play the video again to check your work. Okay? To start now. Let us now check. So we are going to transform the given statements into equations. Okay? So, let's have item number 1. Okay. The variable z varies directly as x. So, the variable z varies directly as x and y and inversely as u. Okay? Were you able to get the correct answer? I hope so. Let's proceed to item number 2. The cost C of operating an appliance varies jointly. Okay. So equals K varies jointly as the number of watts W, that means multiplication. Since joint it involves two or more independent variables, so we have the number of hours H of operation and the cost per kilowatt per hour. So this is just plainly a joint variation. Okay? Next, number 3. The strength F of the beam varies inversely as the cube of L, of its length L. That's it. So it is plainly inverse variation. How about number 4? A varies directly as the cube of B and inversely as the product of C and D. This is combined variation because we have inverse and the direct variation. How about item number 5? The electrical resistance R varies directly as the length L and inversely as the square of the diameter D. Okay, that's it. And how about item number 6? We have P varies directly as L. So we have K times L. And inversely as the square root of G. Okay? I hope you were able to get all 6 items correctly. Now, let's have 4 more items. Okay? Okay, pause the video for a while and then play it when done. Let us check. The volume V of a regular triangular pyramid, so we have the volume V, varies jointly, so we have equals K. So we have 2 or more variables involved here, varies jointly as the altitude A and the square of one of its side S of the base. So this is plainly a joint variation. How about number 8? The weight W of a circular disc varies jointly, so do not forget to write K, varies jointly as the square of its radius R and its thickness S. And for number 9, the volume V of a regular triangular pyramid varies jointly as its altitude A and the square of its radius. I think number 7 and number 9 are just similar. We just make use of a different variables. And then we have the last item, the force F attraction between two bodies varies jointly as the masses m sub 1 and m sub 2 and inversely as the square of the distance between them. Okay, very good. I hope you were able to get the last four items correctly, because if you were able to answer all of this, then you can successfully answer the rest of the problems given to you in this lesson. Okay, let's have your problem solving. Okay, I'll do the first problem and the next problem will be done by you. Okay, so we have here, I've already taught you the technique. As you read, you write the equation, and then after that, you're going to substitute the given values. Then we have, for the first statement, convert this one into, or translate this one into an equation. So we have here y varies jointly as x and w, and inversely as the square of z. When y is equal to 100, so we're going to substitute the first set of values in the equation. So when y is equal to 100, do not forget to copy k because we are looking for the value of k. And x is equal to 2, w equals 4, and z is equal to 20. Do not forget to square it. Okay? Then we're going to simplify the equation. So we have 100 is equal to 2 times 4 times k. So we have 8k. And then we have 20 squared is equal to 400. Then, what are we going to do to get to simplify rational equations? We are going to get the cross products. Taking note that the denominator of any whole number is 1. So we have 100 times 400 is equal to 4. Then we have 4 zeros here. So we have 1, 2, 3, 4. 4,000 is equal to 8k. 1 times k is 8k. Then to get the constant k, we have divide both sides by 8. So we have 40 divided by 8 is equal to 5. Then we have 3 zeros left here. So we have 5,000 is equal to our k. Then we go back to equation 1, or the first step, to write the equation of combined variation. So we have y now is equal to substituting k with 5,000. So we have 5,000 xw over z squared. Then we read the last statement and substitute the values in the equation. So we have what is y. This is now the unknown, so just copy it. So copy the constant 5,000 and replace or substitute x and y and z. So when x is equal to 1, w is equal to 5, and z is equal to 4. Do not forget to square 4. Then we simplify. So you have 5,000 times 1 times 5. So you have 25,000 divided by, what is 4 squared? 4 squared is 16 and not 8. Okay? That's a common mistake of the students. They are going to mistakenly perform 4 squared as 4 times 2. So we have 25,000 divided by 16 is equal to 1,562.5. This only means that the value of y is 1,562.5 when x is equal to 1, w is equal to 5, and z is equal to 4. Okay, that's it. I hope you can follow and you were able to get it correctly when you were following me as I solve. Okay? Okay, for this second problem, I want you to pause this video for a while and then take some time to answer it and then play the video when done. Let us answer now. Okay? The volume of a wood in a tree V, the volume V, varies directly as the height, so that is equals KH, and inversely, so that's division, and inversely as the girth G. Okay. If the volume of a tree is 100 cubic meters, okay, substitute in the equation. So when the volume is 144 cubic meters, okay, you don't need to write the units here because we are only looking for K, okay? So copy, do not forget to copy K. So we have our height is, when the height is 20 meters. So do not forget to write 20. And the girth is 1.5 meters. Now, the girth is squared, so do not forget to square this one also. Simplify the equation, so you'll not be dividing 20 by 1.5. So we have here 144, which is equal to K. 20 times K is 20K. And 1.5 squared is equal to 2.25. Now, how do we simplify rational equations? We are going to get the cross products. Okay. 144 times 2.25 is equal to, let's move on here. We have 324 is equal to 20K. So, to get K, divide both sides by 20. So, we have now 324 divided by 20 is equal to 16.2. Since we already have our K, then we can now write our equation so that we can solve the problem. So we have now V is equal to, our K is 16.2, our times H divided by G squared. Just copy. Then we make use of this equation to solve for the unknown. So the unknown is, what is the height? This time, the height of the tree. So the height is unknown, so copy H. Copy 16.2, the constant. With a volume of, so our volume is 1,000 cubic meters. And the girth of 2 meters. Okay, let's move on here. So, let us simplify first the equation to avoid confusion. So, we have 1,000 cubic meters is equal to 16.2 times H divided by, what is 2 squared? That is 4. And M squared is square meters. Okay? So, we are going to get the cross products here. So we have 1,000 times 4 is 4,000. Okay. Then we have m cubed times m is m raised to the fifth is equal to 162, 116.2 h. Okay. Then we have here dividing both sides by 16.2. By the way, I think the K here is, we need to eliminate this one. So we have to go back here. So this is square meters, this is cubic meters. So this is, I think K here is m to the fourth, y. So we have here 324 meters here. So it becomes 1 here. So we have m to the fourth. Okay. So the k is square meters times h. Okay. So we have m to the fourth. Okay. We have to eliminate this. So we have 4,000. You have 4,000 divided by 16.2 is equal to 246. 246.91 meters equals the height of the tree. Okay? So that's it. That's how we solved it. Okay? Next is we are going to you are going to answer the next set of problems. Okay? So, for practice, answer this. If y varies directly as x and inversely as z, and y is equal to 30 when x equals 50 and z equals 5, find y when x equals 40 and z is equal to 25. Pause this video for a while and then solve. Then play it when done. Okay, let's answer. If y varies directly as x and inversely as z, substitute, and y is equal to 30, copy k, when x is equal to 50 and z is equal to 5. So solve first for the constant. So we have get the cross products. 30 times 5 is 150 is equal to 50k. Then divide both sides by 50 by 50. So we have k now is equal to 150 divided by 50 is obviously we have 3. So our k now is 3. Then we can write the equation of variation. So we have y is equal to 3x over z. Then we can now solve for y. Find y when x is equal to 40 and z is equal to 25. You can make use of your calculator to easily get the answer. So 3 times 40 is 120 divided by 25. So what we get here is 4.8. Okay. How about the next item? Solve this one independently also. Then after you pause this video, then afterwards you're going to play it to check your work. So let us check. If A varies directly as B, if A varies directly as B and inversely as the square of C, and A is equal to 46, copy K to get K, of course, and B is equal to 12, when C is equal to 6, do not forget to square, simplify first. Then we have copy 46 is equal to K times 12 is 12K. And we all know that 6 squared is 36. We can simplify this. So 12 divided by 12 is 1. 36 divided by 12 is 3. So you have now get the cross products. 46 times 3 is equal to 138 equals K. But if you don't want to do this, you just stay in this solution, say, or in this method, 46. 46 times 36. So you have 46 times 36 is equal to 1656 is equal to 12k. That will be alright. Then divide both sides by 12. Okay. You'll arrive at the same answer, which is 138. It would be alright. Okay. And after that, we are going to write the equation. We have A is equal to, the constant is 138. So replace K with 138. Copy B and copy C squared. Then, you're going now to solve the problem. Find B. So the unknown is B. So we just copy B here. So B is unknown, so copy it. Also with the constant, our A is equal to 23. And then our C is equal to 6 also. Do not forget to square it. Okay? So we have now, simplify this one first. 23 is equal to 138B equals 36. 6 squared is 36 and not 12. So we get the cross products now. Okay. Or you may simplify first before getting the cross products. Or it's up to you. So we have 23 times 36 is equal to, let's have this part here. We have 828 is equal to 100 times 1 times 138 is 138b. So to get b now, divide both sides by 138 by 138. So we have 828 divided by 138. What we'll get is 6. So b is equal to 6 when a is equal to 23 and c is equal to 6. I hope you're getting it. Okay? So for your independent practice and for checking and recording, you're going to answer items 3, 4, and 5 on page 228 of your book. Okay? So, let's go back to, or let's say, have a summary of all the variations that we have discussed so far. So, we have the variations, direct, inverse, okay, in which the equation for direct variation, example of this, y is equal to kx, and for inverse, we have y is equal to k over x. To get a constant, of a direct variation, so we have k is equal to y over x, and for the inverse, we have k is equal to x times y. Now, joint is is like direct variation, but with two or more independent variables. An example of this is y is equal to kxz and the equations that we have dealt with a while ago. Then, the last type of variation is combined variation, which is, of course, a combination of direct, joint, and inverse variation, in which if you're going to translate this statement, y varies directly as x and inversely as z, okay, we can translate this one as y is equal to kx. Remember that direct and joint involves the operation multiplication, and for inverse we have division, and inversely, so that's division, so that is equal to z. Alright, we're done with our lesson. So I hope you were able to understand it. So if you have questions, do not forget to give me feedback or send me message in our group chat. Okay, let's go back now to our learning targets and kindly reflect on this. Okay, now can you confidently say this one to yourselves? I can differentiate combined variation from other variations. I can solve problems involving combined variation. If so, then congratulations. And if not, you may review or watch this video again and try to answer all the exercises I had given. Okay, so thank you for watching, and I hope you are able to understand all of this. Goodbye and God bless.